Hello all, my name is Mikala Vashit Reddy, pursuing my BTech at Institute of Aeronautical Engineering at Computer Science and Engineering of Branch, Artificial Intelligence and Machine Learning. Today we are going to be discussing about hybrid posture detection framework integrating machine learning and deep neural networks. Posture detection is increasingly used in applications such as healthcare, surveillance, virtual environments, and human-computer integration. With growing elderly population and limited healthcare resources, uh, remote monitoring technologies have become essential to help individuals live more independently. Proper posture is key to a healthy lifestyles as it reflects how people position their bodies and limbs. However, the widespread adoption of sedentary lifestyles driven by technological advancements has led to reduced physical activity and muscle strength. This paper proposes a deep learning based approach for automatic posture detection using hybrid architecture that combines convolutional neural networks and long short-term memory. Unlike traditional machine learning methods that rely on handcrafted features, these deep learning models automatically extract meaningful patterns. Furthermore, the study introduces a hybrid method that integrates both deep learning modules like 1D and 2D convolutional neural network, long short-term memory, and bilateral long short-term memory, and machine learning approaches to enhance detection accuracy. Extensive research has been conducted on posture detection using various technologies and machine learning methods. In small cities, posture recognition is enhanced using multisensory input combined with LoRa range technology. Due to this long transmission range and low cost, wearable clothes integrated with sensors and LoRa facilitate comfort and data collection. Multiprocessing techniques like sliding window and random forest-based feature extraction improve accuracy on small data packets. Posture issues, prolonged sitting are addressed using smart cushions and AI-based pressure sensing systems. These devices collect data from different sitting postures, enabling machine learning models like support vector machine, direct latent Dirichlet method, and random forest to detect incorrect postures effectively. SPMS systems with seat embedded sensors show high accuracy using support vector machines with root-based formal kernels. This section outlines the proposed approach for posture detection. Initially, six statistical features: skew percentile, square root, standard deviation, mean, and kurtosis are extracted over a 90-second window to form a new dataset. The primary challenge lies in identifying the best combination of features to optimize prediction accuracy, since manually extracting all features combinations with machine learning models is time consuming. Deep learning methods are employed as they eliminate the need for manual feature engineering and often yield superior performance. Various ML classifiers, including SVM, logistic regression, K-NN, decision tree, naive Bayes, a random forest, linear Dirichlet allocation, and Quadratic descendant allocation are used to evaluate the model's performance. These classifiers are implemented using scikit-learn packages, and their training parameters and times are presented in respective tables. For deep learning component, a novel 10-layer convolutional network framework is introduced, comprising convolutional max pooling and fully connected layers. To further enhance accuracy, a hybrid model integrates predictions from both machine learning and deep learning classifiers. Outputs from machine learning and deep learning models are served as input features for meta learning of convolutional neural networks and LSTM architectures. This ensemble strategy strengthens the overall system's predictive capability. The configuration of each classifier in hybrid model is empirically tuned through extensive simulations, and architecture is visually depicted in referred figure. So, coming back to results of this experiment, to classify human posture, a total of 13 experiments were conducted using traditional machine learning classifiers uh, like logistic regression, random forest, KNN, and deep learning models like 1D, 2D convolutional neural networks, L linear LSTMs, and bilateral LSTMs. Six feature skew. Six features are considered: skew, percentile, square root, standard deviation, mean, and kurtosis were extracted from training. A tenfold cross-validation strategy was used to ensure reliable evaluation. The performance metrics employed including precision, recall, F-score, and accuracy with their standard formulas provided to access each model's effectiveness in posture classification tasks. The experiments use a publicly available benchmark dataset collected using galvanic skin responses from by Telino kits. The dataset includes data from uh, five individuals aged 25 to 30 across three posture classes: sitting, standing, and walking. Data samples ranging from 5 to 10 minutes recorded an 16-bit resolution with 1 megahertz sampling rate. All ML models were trained using Python's scikit-learn library, while deep learning models utilized TensorFlow as a backend. Results show that using all extracted features together yielded high performance, while using only mean feature resulted in lowest accuracy. As you can see here, all the all how all the networks are being built. For example, here at convolutional, this table actually represents the actual architecture of LSTM, and this image here represents how the workflow of the project, where first initial raw data is taken, which is pre-processed, and then it is served to both deep learning and machine learning models, where it is infused with each other, where deep learning and machine learning models extracted input features are then infused together to form a reliable posture result. And here is what it is. So these are all typical ML tasks, and these are all typical deep learning tasks which are infused together to form a hybrid task as proposed in the research paper. The experiment results demonstrated that combining all features generally leads to better performance across multiple classifiers. Specifically for random forest, using all features produced the highest accuracy, while using only mean and standard deviation resulted in lowest performance. In contrast, the naive Bayes model performed best when using combinations like mean and standard deviation and mean standard deviation and square root, whereas adding percentile to that mix reduced accuracy. For linear discriminative analysis, the best results were obtained using combination of mean, standard deviation, standard reduction, and percentile features. And here you can see all these tabular values, which actually summarizes all the ML models which are used in the experiment. And here is all deep learning models which are being used in this model. And to conclude this topic, the remote health monitoring is important for providing independent living to elderly and vulnerable. Therefore, in this paper, the community produced a novel architecture based deep learning classifier to identify posture, including standing, sitting, and walking. In addition, the novel hybrid approach are developed based on deep learning methods to identify the posture prediction. So that's all for today, guys. I hope you to see in my next video. Until then, thank you.